Okie dokie, folks. So today we're going to go ahead and finish up section 3.7. Yes, 3.7. Talking about quadratic inequalities. The last thing we did yesterday was we saw how to solve a quadratic inequality algebraically. That means doing it without graphing. And the answer to that was factor, use a sign diagram, and determine if you look for positive or negative zones. We're going to be doing that again today at the end, down here, when we compare two quadratics to each other. One of the things that we did yesterday was we graphed quadratic inequalities and shaded. If you can turn an inequality into a graph, then you should be able to turn a graph back into an inequality. So that's all we're going to do here. So let's talk about what we notice. What we notice is, first of all, that is a dotted quadratic. That means there will not be an equal to sign on our inequality symbol. What else do we see? We also see that the shading is below the vertex, which tells us that the inequality symbol that we're using is a less than symbol. If the shading had been above the vertex, then it would have been a greater than symbol. And remember, because it's a dotted quadratic, we do not have an equal to bar underneath our inequality symbol.
So if it's above the vertex.
If it's above the vertex.
Can you shade inside?
Well, let's not say inside and outside. Let's look at what we did yesterday. This one says less than, so it's shaded below the vertex. This one also says less than, so it's shaded below the vertex. This one says greater than, it's shaded above the vertex. So let's not say inside and outside because it doesn't matter if it's inside or outside. What matters is the shading above the vertex or below the vertex.
So if y is greater than your inequality, then it will be shaded above the axis.
Yes.
Above the vertex?
Yes. So if it says y greater than, your shading will happen above the vertex, and that doesn't matter if the quadratic points up or down. That's not important. Y greater than, shading above vertex. Y less than, shading below vertex.
And it goes, or if you have the bar underneath it, the symbol too? Okay.
Yep. Well, yeah, and because the bar underneath, all it does is tell you if this thing is dotted or solid. That's all that does.
Okay.
Now, since we're trying to write the equation of this thing, we have two options. We could either use vertex form if we have a pretty vertex, or we could use intercept form if we have pretty x-intercepts. What you never want to try to do is write an equation in standard form. It's just a pain in the butt. It's not worth the effort. And in the homework, I know there's at least one of the questions where you could choose vertex form or intercept form. So don't freak out if your answer doesn't match mine. You might have just used a different form than I did. But this one, I can see that my vertex does not have a pretty y value. And because my vertex does not have a pretty y value, I do not want to try to use vertex form. Instead, I will notice that I can see pretty x-intercepts, so I'm going to use intercept form. There. P and Q are the two things that I just circled. So we'll say this one's P, -4, and we'll say this one's Q, +2. So this is going to say -4, and this is going to say -2. As of right now, our quadratic inequality says y is less than a times x plus 4 times x minus 2. All we have left to do is solve for a. And solving for a is going to be done the exact same way it was done at the beginning of this chapter and the exact same way it was done in chapter 1 when we were trying to find the equations of absolute values. All you have to do is plug in a pretty point and solve for a. It's the exact same thing that we've done the last 2 times that we've had to find equations from graphs. Plug in a pretty point. So identify a pretty point that your quadratic goes through. I see one right there at the y-intercept.
Can I ask a question?
Of course you can ask a question.
So you said that if, sorry, I'm something in my eye. If you shade above the vertex, it'd be y is greater than.
Yes.
But
Shading above is y greater than.
yeah, I'm looking at the graph, but they're shading below and above.
No. Your vertex is right here.
Yeah.
So the shading above the vertex would be here.
It wouldn't be outside.
No, don't worry about inside, outside. Just look immediately above or immediately below. Okay? Now, I'm going to use 0, negative 6 to solve for a. So plug in a pretty xy and solve for your unknown a value. I know that it doesn't say y equals, but since we're solving for a, I'm going to write equals. So I've used 0, negative 6, and I've plugged in to x and y. If you simplify and multiply right here, this is 4 times negative 2. That's negative 8. Divide both sides by negative 8 and reduce. Negative 6 over negative 8 reduces to 3/4. That means we have found our entire quadratic inequality.
That would mean the sign flipped?
Well, no.
If you divide it by negative.
No. There was no inequality here because I'm just trying to identify what a is.
Okay.
Y less than 3 over 4 x plus 4 times x minus 2. And there it is. If you wanted to confirm that you did it right, you could find the vertex of this. Halfway between negative 4 and positive 2 is negative 1. So if you plug in x equals negative 1, we had better get a number that's almost negative 7. Let's see. That's going to give me a 3 here. Negative 1 plus 4, that's 3. Negative 1 minus 2, that's negative 3. So this is negative 9. 3/4 of negative 9 is negative 27 divided by 4, almost negative 7. Because negative 28 divided by 4 would have been negative 7. So it worked perfectly. Ta-da! Do you have any questions for me about finding the equation? Especially for those of you that weren't paying attention at all while I was doing it. None of you? Okay. I'm just going to say one time, you cannot ever just know the a value without showing work. There is no way to just know this a value. You will show work in the homework, or I'll just assume that you got there nefariously. You can't see it. No, you can't. You just can't. I'll assume you can't. All right, here we go. Here we have a system of quadratic inequalities. Now, we've done systems of inequalities before. That was just when we were graphing 2 straight lines and then shading in 2 places and we were looking for the double shade. That's all we're doing. They're just going to be U-shaped instead of straight lines. So we're going to get 2 U-shaped graphs. We're going to shade for both of them, and we'll find the zone that is double shaded. The only wrinkle is that this thing is written backwards. So for this top one, I'm just going to write it in the correct order, and for us, the correct order is the y on the left. That way we know immediately if we're going to shade above or below the vertex. Notice that the inequality symbol is big on the y side, so writing it backwards, the inequality needs to still be big on the y side. There. And we'll just kind of separate the space. Make a prediction about what this is going to look like. Well, that 2 is a positive number, so this quadratic points up. And there is no equal to bar, so it's a dotted quadratic that points up. Lastly, where it's shaded. Well, it says y greater than, so that means I have to shade immediately above the vertex, which is going to look like that. Darken it up a little bit. There we go. So it'll look like that. This is vertex form. It shows us our vertex. Vertex is going to be at what makes the inside equal 0, negative 3, comma the number to the far right, negative 8. Because transformations, that says go left 3, go down 8. That puts your vertex here. We do need a couple more points though. Our axis of symmetry happens to go through like that. And the only reason why I care about that is because if I find a point on one side of it, I can just reflect it to the other. And your denominator here is a 1. That means you can scoot to the right one or to the left one to plug in your next x. So I want to go right one. I want to use x equals -2. I'm going to plug in x equals -2, and I'm going to get my y value. I'm aware it doesn't say y equals, but since I'm trying to track down a variable value, I'm going to write equals. The cool thing about using -2 is that the inside of these parentheses becomes a 1. -2 plus 3 is 1, and 1 squared is 1. So it cleans up really nicely to just be 2 times 1 minus 8, which is -6. That means there is a coordinate at -2, -6. That's right here. If there's a blue dot 1 to the right of the purple line there, there's a blue dot 1 to the left of the purple line there. And you could just try to draw your U-shaped graph. It's going to be kind of skinny though, and we're kind of close to the bottom of the graph here. So I went ahead and plugged in another number earlier just to see. I was curious to know where it would cross the x-axis. When you cross the x-axis, no, excuse me, the y-axis. When you cross the y-axis, what does x equal? Anybody, if you're on the y-axis, what does x equal? 0. All right, so if we put a 0 here, we get 0 plus 3, which is 3. Squared is 9. Times 2 is 18. 18 minus 8 is 10. Turns out this thing crosses the y-axis at 0, 10. That is 3 to the right of the axis of symmetry, so 3 to the left of the axis of symmetry is -6, 10. So as I said, it is a skinny looking parabola because that vertical stretch that's on the front, that 2. Do your best to connect these dots with a U-shaped graph. And we've already identified that because it's got the greater than symbol, our blue shading will be directly above that vertex. So it'll be like this. I chose not to do that in blue just because it was going to look a little crazy here in a minute. So I figured I'll just use pencil so it's easier to look at. And now, for our other quadratic, I'll do that one in red. So what do we see? We see that it points down because this number is negative, and because it's got an equal to symbol, it's a solid line. I chose red and blue because they make purple. They look like purple to me. Anywho, because it says less than, I know I'm shading directly below my vertex, so that'll be like this. And now we're ready to rock and roll. Unfortunately, standard form doesn't give us much information. Really, the only thing it gives us is the y-intercept. And the only reason why it gives us the y-intercept is because no matter what, for every single graph, forever, ever, and ever, if you're on the y-axis, x equals 0. And if you substitute x equals 0 for here and here, what you get is 0 plus 0 plus 6, you get 6. So my y-intercept happens to be positive 6. Of course, without an axis of symmetry, I can't reflect that over anything. I guess I need the axis of symmetry. Standard form, the axis of symmetry is x equals -b over 2a. So we have negative, our b value was -2. On the bottom, we have 2 times our a value, which is -1/2. Positive 2 over -1. That gives us x equals -2 is our axis of symmetry. Okay, now that I have an axis of symmetry, I can reflect that red dot over it. If there's a red dot 2 to the right of the axis of symmetry, there's a red dot 2 to the left of the axis of symmetry. And since it points down, I know my vertex is somewhere above those 2 red dots. Just need to find that vertex now. This is the x value of the vertex. Substitute it into here to figure out what y equals. And I know it doesn't say y equals, but since I'm looking for the value of a number, or excuse me, of a variable, I'm going to write equals. Hardest part about this is just following the order of operations. Remember, exponents come first. I have to square this -2. It's going to get me 4. -2 times -2 is +4. And then I got a 6 over here as well. Half of 4 is 2, but it's negative. So I have -2 plus 10, which is +8. My vertex then is at -2, 8. Way up here. Now just draw a downwards facing U-shaped graph to the best of your ability. That might be too wide. I don't know. I don't really care. And then shade like that. Now we just identify the zone that has been double shaded. And I hope that you can see that it's here. Ta-da! Yes?
Why would you shade inside for the second one?
So let's not say we're shading inside. Let's say I'm shading below the curve. Because it says less than, I'm shading underneath the curve. Or directly underneath its vertex. Just like this one was shaded directly underneath its vertex, which is why it's a less than. So anytime you see y less than, you're shading directly below the vertex. And if you see y greater than, you're shading directly above the vertex. So where I'm shading has to do with which way the inequality points, not which way the quadratic points. Any other questions on that one? And everybody's cool with what's going on there? All right. Can we agree that the purple stuff represents all of the places where the blue graph was underneath the red graph? Do we see that? So everything purple shows me all the places, at least all the x values, where my blue dotted graph was underneath my red graph. This is what we're doing when we solve this algebraically. But we're just going to do it without graphing. But literally what we're doing is finding all the places where this U-shaped graph is less than, which means under, this U-shaped graph. And we're doing that without graphing. The way we're going to handle that is we're going to get everything onto one side, combine all of our like terms, solve by factoring, and then we're going to do a sign diagram just like we did yesterday. You see, when we go to do these sign diagrams, though, we need everything in standard form so we can factor it. That's already in standard form, but that's not. No, you can copy one of the ladies across the table from you, or you can watch the video on YouTube. Or you can just do the notes with me when I do them. Here, we have x plus 3 quantity squared. That means x plus 3 times x plus 3. You are going to have to FOIL here. Since this is Algebra 2 Honors, I'm just going to go ahead and assume that you all know how to FOIL. And the left-hand side has been unaffected. Oh, excuse me, the right-hand side. I know my left and my right. Who said I didn't? There. I know I could combine like terms, but the point is, now that everything is in standard form, I can move everything to one side. Because you can't solve by factoring unless you move everything to one side. I don't like to factor if my front number is negative, so I'm going to move all this stuff to the right. I can know my, man, to my left. Okay, that's twice now I've screwed that up. Maybe I don't know my right from my left. Anyway, I'm going to take all this stuff over here and bring it over here. Here we go. I'll start saying here and here instead of having to use directions because they make me look unintelligent. Anyway, so we're going to add x squared to both sides. We're going to add 2x to both sides. And we're going to subtract 15 from both sides. Like that. On the right side, I now have, see, I got it correct that time. On the right side, I now have 0. Why did I make, there's no fractions on this. I don't know what you're talking about. Anyway, x squared plus x squared is 2x squared. 6x plus 2x is 8x. 9 minus 4 is 5, and 5 minus 15 is negative 10. And we're solving by factoring. The first thing you always hunt for when you're factoring is a GCF. That's not guaranteed there will be one, but you always look. This one has one. That GCF is 2. And once again, I make the notes so that they're easy to get through in a class period. So I don't have a number in front of x squared, so I don't have to use the Lizzie method or slip and slide or slide and divide, whatever you want to call that method for factoring. You will have to in the homework and on the tests and things like that. So just make sure that you know how to factor. Anyway, we're looking for the two numbers that multiply to negative 5 and add to 4. Those two numbers are 5 and negative 1. If it had said equals 0, then now we can easily see what our x's would have been. They would have been x equals negative 5 and x equals positive 1. But since it doesn't say equals 0, because it's an inequality, what we're going to do is make a sign diagram with those two x values on it. Please remember what a sign diagram is. It's just the x-axis. And when we put our pluses and minuses on it, what we're doing is we're deciding, would my y values have been positive here or negative here? That's what we're doing. These two x values chop our number line into 3 zones. All we have to do is figure out what kind of y values each zone would have produced. We do that by taking a candidate out of the zone. It doesn't matter what you choose, just something out of this zone, and plugging it in. She says negative 2. Unfortunately, negative 2 is not to the left of negative 5. Negative 7. Okay, negative 7. Why not? All right, check it out. This 2 is positive no matter what you do. Negative 7 plus 5 is negative. Negative 7 minus 1 is negative. This is a product of 3 numbers. I plugged in negative 7.
Yeah, but for the 2, why do you put that there?
In case it was negative.
Yeah, but you realize that it's not.
But what if it is?
No, if you look at it.
But what if it is? You see, here's what's up. I like to have one way of doing things and sticking to that one way. That way I don't have students trying to memorize patterns that sometimes work and sometimes don't. Okay, yes ma'am?
How did you get positive?
Because 2 is positive. I'm multiplying these 3 numbers.
So you went times the negative 7 times 2.
I don't actually care what the digits are. I just want to know are they going to be positive or negative.
But if you take a negative number and you, like, are you just not plugging it in? So
No, I took negative 7. I see that I have a positive 2 times a negative number times a negative number. And if you multiply a positive 2 and 2 negative numbers, you're going to get a positive number.
So if it was 2x,
We,
that would be negative.
yeah, if there was an x out there where you could actually plug something in, then yeah.
Okay, but you won't plug it in if there's no x.
Right, you can only plug in where x is.
Okay.
But this is a number and it's positive, so I want it to be represented here.
Okay, yeah.
I'm showing the symbols that you'd get in these three zones when you plug in an x. So if you plug in -7, this one's symbol's positive, this one's symbol's negative because -7 plus 5 is negative, and this one's symbol is negative because -7 minus 1 is negative. Now, in this zone, I could plug in any test number. 0 is a friend. I like plugging in 0. 2 is positive no matter what you do. 0 plus 5 is positive. 0 minus 1 is negative. The product of these three kinds of numbers will be negative every single time. And then lastly, grab any number that's bigger. Oh, yeah?
I'm confused like with the plus and minus. Like what are they even?
She just asked me that. Okay, one more time. Take a test number from the zone and then plug it in to these three things and see what kind of symbols you get. No matter what, 2 is 2. 2 is a positive number. If you plug in a number out here like -7, right there, -7 plus 5 is a negative number. -7 minus 1 is a negative number. The product of these three digits will be positive. And then here we plugged in 0. 2 is positive. 0 plus 5 is positive. 0 minus 1 is negative. And well, we're not there yet. And then lastly, I'm going to grab a number bigger than 1, like 2, and plug it in. No matter what, 2 is always positive. 2 plus 5 is positive. 2 minus 1 is positive. The product of three positive numbers will always be positive. Now we need to decide which ones we wanted to find. It says the quadratic needs to be less than 0. And what kind of numbers are less than 0? Negative numbers are less than 0. Since it does not have an equal to bar, these are not included. But everything in between them resulted in a negative value. Therefore, my solution set is from -5 to +1. Those are the x's that will guarantee that this quadratic is underneath this quadratic graphically. So if you're one of the people that's struggling with this sign diagram, please write more things in your notes than I did. Okay? Please. Because this is not the first time we've used sign diagrams. And it won't be the last time we use sign diagrams either. Alrighty, nerds. That's it for today's short conclusion.